Hello, welcome to this video. Today we're looking at this problem. So we have n to the r minus 2 is equal to k factorial, where n, k, and r are natural numbers, and r is at least 2. Now, this is a modification of a problem that a guy named Michael Penn did a couple days ago, where his power r was just 3 and n and k were natural numbers. But then when I solved it, I saw that you can generalize the power to any natural power r, but it has to be at least 2. Because if r was 1, you would obviously have infinite solutions. So, let's begin. So, the first thing that I want to do is look at the specific case of k is equal to 1, and to show that that has no solutions. So that will be very easy. We have n to the r minus 2 is equal to 1 factorial, which is 1. So n to the r is equal to 3, and because r is a natural power that's at least 2, and n is a natural number, this equation is impossible. N, because r is at least 2, n would have to be 1 or 2. If n is 1, we get 1 is equal to 3. If n is 2, we get 2 to the power of something is 3, which is impossible. So in short, that's the explanation of why this can't work. So now, that's the case of k is equal to 1. Now, now we know that k is at least 2. And if k is at least 2, that implies that k factorial is even, or it's divisible by 2, or it's congruent to 0 mod 2. And that means that k factorial plus 2 is also even. So I'll just write k factorial plus 2 is even. But we know that k factorial plus 2 from our equation is n to the r, meaning that we have n to the r is even. And you can see how that implies that n itself is even. And now if n is even, we can write that n is equal to 2m, where m is also a natural number. And now we can substitute that in, and we get 2 to the r times n to the r minus 2 is k factorial. Now we can take out 2 out of this, out of the left-hand side, to get 2 times 2 to the r minus 1 times m to the r. That minus 1 is k factorial. Now, because r is at least 2, and it is a natural number, r minus 1 is just a positive integer, meaning that 2 to the power of r minus 1 is even. M is a natural number, so I'll write it here so we don't forget. M is a natural number, meaning that m to the r is also a natural number. And because 2 to the r minus 1 we showed is even, and just now, that means that this entire thing is even. An even number minus 1 is odd, so this whole bracket is odd, meaning that we have 2 times an odd number is equal to some natural number factorial. Now, from the point k is equal to 4 and onwards, k factorial starts to be divisible by 4, because 4 factorial is equal to 24, and then every other factorial is just natural numbers times this. 5 factorial is 5 times 4 factorial, factorial is 30 times 4 factorial, and so on. So all of them are divisible by 24, meaning that they're divisible by 4. From the point k is equal to 4 and onwards. So k is at least 4 means k factorial is divisible by 4, and k is the other cases of k is equal to 2 and 3. We have k factorial is equal to 2 and 6, which aren't divisible by 4, but are still even. And k factorial cannot be divisible by 4, since k factorial is 2 times an odd number. If k factorial were to be divisible by 4, we would get, if we would divide by 2, we'd get something odd, something even, and that's impossible. So k is not at least 4. We showed that k isn't 1, and just from looking at that special case. So k is 2, or k is equal to 3. So now let's clear the board and then quickly look over those two cases. Alright, now first case, k is equal to 2. If k is equal to 2, we substitute in our original equation, we get n to the r. Minus 2 is 2 factorial, which is 2, meaning that n to the r is equal to 4, which, as a power of at least 2, can only be represented as 2 to the 2, means that, in this case, n and r and k are all 2. So, and in our second case of k is equal to 3, if we substitute that in, we get n to the r minus 2 is 3 factorial, which is 6, implying that n to the r is equal to 8, which, as a power of at least 2, can only be represented as 2 to the 3, meaning that, in this case, we have n is equal to 2, and r and k are 3. So let's officially write these solutions down. We have the triple n r k equaling 2, 2, 2, or we have it equaling 2, 3, 3. And as we showed, those are the only solutions to our original equation. N to the r minus 2 is k factorial. And finally, that's it. If you want more content like this, please subscribe to my channel. I'll be uploading more interesting problems like this in the future. And finally, that's it.